Welcome to this short screencast on polymer properties and applications, and specifically CES EduPack 2017. To start off, we're going to do a quick recap on what you should have experienced on CES EduPack up to date. So, there was 6 introductory databases as outlined below, and most notably the 2 that you would have worked on would be level 1 and level 2. So what did you find in the level 1 and level 2 databases? Well, we look initially at level 1, which contained information on greater than 60 materials and 70 processes. In level 2, there was information on 100 materials and 110 processes, but more specifically we had information on 29 polymer and elastomeric materials and 8 polymer processes as outlined below. So we have the 29 polymer materials outlined and the 8 polymer processes. So as a quick exercise for the next day, I'd like you to look at the 29 polymer and elastomeric materials and subdivide them into either crystalline or amorphous materials and provide that information for class. Now, we're going to have a quick look at the level 3 databases and how it changes greatly from what you would have experienced during level 1 and level 2. So, again, we have 6 level 3 advanced databases, and these are outlined below. And the 2 databases that we're going to be looking at during these classes is the level 3 polymer and the level 3 bioengineering. So, what can we expect to see in the level 3 polymer database? How does it differ greatly from level 1 and level 2? Well, for a start, there's greater than 3,900 materials reviewed and 240 processes. And it provides increased information on trade names, filler type, impact properties, and chemical resistance of the various materials. But not alone that, this is also supplemented by campus plastics and prospector plastics databases. So what do these contain? The campus contains more than 6,000 comparable plastic resin specification sheets and ISO standard data. Prospector has more than 96,000 plastic resin specifications and processing data sheets directly from the vendors worldwide. I'm now going to run through a quick example of polyethylene. So polyethylene has the chemical structure as outlined below. So we can see it's a hydrocarbon material with quite a high molecular weight. What I've done next is I've looked at the 11 PE grades which are outlined within the level 3 polymer database. And again, these are outlined below. So they vary from general purpose molding and extrusion grades right up to wire and cable grades. If we look at the different polyethylenes in terms of tensile properties. So a quick plot using the CES EduPack level 3, we can plot polyethylene grade versus tensile strength and also color code. So what we can see is that there's a range of tensile strength properties depending on the grade of polyethylene you use. And again, I've just summarized the tensile strength values, and they range from less than 10 megapascals up to greater than 60 megapascals, depending on the grade. Now, another very important characteristic is going to be price. So, how does these grades of polyethylene differ in price? So again, by using the database, we can do a plot of polyethylene grade versus price. And again, I have that color coded below. So we can see that the polyethylene medium density, molding and extrusion grade has the lowest price. However, when we look at some of the polyethylene cross-link grades, that has increased significantly. So it ranges from less than 100 or less than €1.50 per kg to greater than €4 per kg, again depending on what the grade is. Right, so what are we going to be doing over the next number of weeks? Well, we're going to be carrying out a number of exercises using the Level 3 Polymer CES database. And the first exercise we're going to carry out is we're going to be looking at a suitable material for an automotive headlight lens. So here I've outlined the background. So the lens of an automobile headlamp protects the bulb and reflector and focuses the light where it is most needed. Therefore, this project is to use CES EduPack to select materials for the lens. Simple objective: to select materials that meet the requirements for the lens. And we have the requirements outlined below. Number 1, the lens must be transparent with optical quality. Number 2, it must be able to be moulded easily, because we're going to be manufacturing large quantities of these headlight lenses. Naturally enough, it must have good durability in fresh and salt water. It's going to be exposed to UV radiation, so therefore it must have good durability to UV radiation. Good abrasion resistant, meaning a high hardness. And finally, it needs to be low cost. So that's the first exercise outlined, which we're going to start into during next week's class. So thank you for viewing this short webcast, and talk to you next week. Thank you.